equipment earthing. So this is the equivalent circuit. This is source voltage, motor equivalent equal to a small resistor in series with a large inductor, and this is a switch provided in return conductor. This is equivalent resistance of enclosure. This is equivalent resistance of human. So this is total equivalent circuit. As the supply is connected to the motor and switch is provided in neutral, the motor is continuously live. Till this point, the motor is continuously live. If there is a short circuit between motor winding and enclosure, this is a short circuit, the enclosure will receive voltage. Till this point, the circuit is not closed. When a human comes and makes contact with the enclosure, then the circuit is closed. Through the human body, it is connected to the ground and a return conductor. So in this way, the circuit is closed. Here the human is closing the circuit and the fault current flows through the human body. Even though switch is provided in neutral and it is still open, but the circuit is closed. The switch has to be provided in phase only. In neutral, we can go for neutral links. The advantage of neutral link is during testing, link can be opened, and during faults also link can be opened and approximate location of the fault can be identified. These are the advantage of neutral links. So what if the equipment is connected to ground? Supply voltage, motor, switch is provided in neutral, return conductor, but the equipment is grounded first. And at the same time, if there is a short circuit from voltage to enclosure, during the same time, if an operating person comes and contact with the enclosure, at this point, for this fault current, there are two routes. One is through enclosure and through human body to ground. The other one is directly to the ground. The current always takes low resistance path, so the current is taking directly ground path. This ground path is done by the third core of the cable, that is earth continuity core. So in this way, the human can be protected. The risk of fire and risk of short circuit can be minimized with the help of grounding the enclosure. This is the third core of the cable. One is phase core, one is neutral core, one is earth core. Earth core has to be continuous throughout the line. If there are any openings in the earth continuity core, then there is loss of earth continuity, and again risk of fire, risk of short circuit and shocks all will be in picture. So in order to avoid this, first earth continuity is provided at the same time and protective equipment also provided. Protective devices, type of protective devices, either switch fuse connection or MCB, MCCB with ELR CBCT connection, circuit breaker, CT and relay. So by providing these protective equipment, we can protect the circuit and equipment from overcurrents and short circuits, so that we can minimize the risk of fire and shocks. Depending upon kilowatt rating of the motor, we can go for either 2-core cable or 3-core cable. We have to check the cost effectiveness. If the motor rating is very low and the distance between the motor and the source is very less, then we can directly go for 3-core cables, whereas the 3rd core can be used for earthing of the motor. If the length of the cable or the distance between the source and equipment is very large and kilowatt rating of the motor is also very large, in that case we can go for 2-core cable and local earthing can be provided. The local earthing means either we can go for a grid earthing, pit earthing or rod earthing. In case of 3-phase motors, we can go for either 3-core cable or 3.5 or 4-core cable. The 4th core is connected to ground, but this 4th core is connected at equipment and it is totally traveling along the length and it is connected at source grounding. So these are the important points regarding grounding of the enclosure or earthing of the enclosure. Few more points we have to discuss about the fault current. For example, we are considering the supply voltage is 240 volt. Distance of enclosure is nearly 4 kilo ohm. Distance of human is around 20 kilo ohms. The fault current I equals to V by R. So the total fault current is approximately 10 milliampere. Up to 10 milliampere, nearly severe shocks. From 10 to 20 milliampere, fatal accidents. So this is the total analysis of equipment earthing.